Welcome again. So this is we are studying again the third chapter. So in the last lecture we have studied the types of bonds, right, and lots of other things. And this chapter we will further go to the chemical bonds and the naming compounds and etc. So now let's see. We have studied last time the types of the bonds, right? Covalent bond and ionic bond, etc. And we discussed that covalent bonds formed by the electron sharing and ionic bond formed by the electron donation. But let's go further in that. So in the point of view of the electronegativity, how we can classify the bond. Okay, so electronegativity is the property of the element that it can have the capability of holding electron or accepting the electron. So how strongly one element can hold the electron, that the electronegativity, or how strongly it can pull the electron toward itself. It means the property of the electron accepting. So for example, oxygen is more electronegative. It will attract the electron toward itself more strongly than the, for example, hydrogen, right? So these are the values of electronegativity. Let's see that in the electronegativity of all these periodic elements. So hydrogen has 2.2, and the helium has not known. They are the inert gas, so they don't accept the electron, right? But the krypton, xenon, they can. See, they have the electronegativity value. So similarly, boron has 2, carbon has 2.6, nitrogen has 3, oxygen has 3.4. Fluorine, you see that in the periodic table, this is the highly electronegative, means highest electronegativity the fluorine has. See, it is 4. So all others are less than that. If you see that none of them is 4. So all the elements on the periodic tables are less than fluorine. So fluorine is the highest in the electronegativity series. Okay, this is the electronegativity. So if you make the bonds between two or more than two elements, means the bond is always between two elements, right? So let's say the bond between two elements, any two elements, we can have the electronegativity difference then. For example, let's make the hydrochloric acid, HCl, right? H is hydrogen, chlorine is the non-metal, so you can say that this is a covalent bond. But now let's see the electronegativity difference. Hydrogen is 2.2 and the chlorine is 3.2. So the difference, electronegativity difference delta E is equals to 3.2 minus 2.2 is equals to 1. This is the electronegativity difference. So if you think about the hydrofluoric acid, HF, then electronegativity difference will be hydrogen is 2.2 and the fluorine is 4. So 4. So let's say this is minus this plus 4. Okay, 4 minus 2.2, and that is equals to 1.8. So 2.8. So 4 minus 2.2 is about 1.8, right? So 1.8. So this is 1.8. Let's say hydrochloric acid 1, hydrofluoric acid 1.8. Similarly, if you think about the sodium chloride, now let's say the sodium chloride. Sodium chloride electronegativity difference is chlorine is 3.2 minus sodium is 0.9, right? They have less tendency of accepting the electron, and that is about 2.3, right? 2.3. Look at that, 2.3 is sodium chloride. Okay, so similarly, potassium chloride, KCl, you see that potassium chloride, and chlorine is 3.2 minus potassium is 0.8, and that is about 2.4, right? So that is KCl. So for example, magnesium chloride, if you see magnesium chloride, MgCl2, right? So means that the bond will be between magnesium and one chlorine, right? Magnesium, chlorine, chlorine, right? So it's making magnesium and the chlorine. So MgCl2, it's magnesium and chlorine bond. So delta E equals to chlorine is 3.2 and minus magnesium is 1.3, right? That is equals to 1.9. So you see, and similarly carbon and hydrogen, right? CH3, for example, carbon and hydrogen. Let's say carbon and hydrogen. Okay, so carbon and hydrogen. Let me erase this. Carbon and hydrogen. Okay, carbon and hydrogen. If you see the carbon and hydrogen, now let me erase that. Okay, sorry about that, guys. Okay, now if you see the carbon and hydrogen, okay, carbon and hydrogen, see carbon and hydrogen, right? Carbon CH3, suppose CH, right? This carbon and hydrogen, that is, what is the carbon? Carbon is 2.6 minus hydrogen is 2.2. Oh, 2.6 minus 2.2, it is 0.4. See, okay, some has 0.4, some has 2.3, some has 2.4. So the electronegativity difference can be any, right? So but that could be greater than 0, less than 2.5, like that. Okay, so we have the electronegativity difference, and that's why if there is the electronegativity difference, then the bond can be formed. But the same, for example, the hydrogen and hydrogen. So hydrogen and hydrogen, right? Hydrogen is 2.2, other hydrogen is 2.2, it's 0. So there is the electronegativity difference between the same atom, diatomic, same molecule, same diatomic molecule, then the electronegativity difference is 0, right? So now we learned here some electronegativity difference is there to form the bond, and that electronegativity difference can be 0 also. So that 0 is for the diatomic molecules. Same diatomic molecule means that so the atom types are same. So for example, hydrogen, H2 gas, nitrogen, like that. So this is the electronegativity difference. Okay, so further let's recall again. The ionic bond means transfer of electron, and the covalent bond means sharing of the electron. But actually the sharing of the electron, what do you mean by the sharing of the electron? Now let's see two things. This is one, it has a proton nucleus, and it has also electron also, right? There is another atom which has also proton and which has also electron. Say if ionic, then this one atom will transfer the electron to another, and then it will have two electrons, it will have one less electron, that's why it will be positive, it will be negative, and then it is ionic. But sharing of the electron means a little bit different than ionic. In previous case or ionic case, this will give the electron this guy, and now it will have one less electron, and that will be positively charged, and it has two electrons, that's why it will be negatively charged, and this positive will attract this negative. This whole thing, species, will attract this whole thing. So one will act as a south pole of the magnet, other will act as a north pole of magnet. That's the analogies, right? So positive attract negative, and that is the ionic. But in case of the covalent bond, it's little bit different. Okay, let's see that. What is the sharing means? Proton and one electron, and other has also proton and the electron. So instead of sharing electron, what it does in case of the covalent bond, this proton will attract this own electron. This proton also will attract the electron of another guy. If they come closer, then this proton also feel the electron of another atom also, and not only its own electron, but it also feels the other guy's electron also, other atom's electron also. And similarly, this proton attracted this electron also, and that proton also attract this electron also. So this kind of the electron. So one other thing is simultaneously these two electrons repel each other also, and these two protons repel each other also. So this kind of the complex situation, everything, attraction and repulsion is there, but this attraction wins. This attraction wins. It can remove all, it can cancel all the repulsions, and finally the attraction wins and they live together. That kind of bond is said to be the covalent bond. So that's why in both cases the role of the electron is there. So now, so one other thing, now let's, before going the covalent bond and ionic bond according to the electronegativity difference, now let's see something more. Okay, that is the charge of an atom. How much charge? What could be the charge? So on the basis of the inert gas or the noble gas, then we can predict the charge, how much charge can have an electron. For example, oxygen can have -2, chlorine can have -1, sodium can have +1, hydrogen can have +1, right? Hydrogen cannot be +3, sodium cannot be +3, like that. These are. So how do you know that? What could be the charge, right? So magnesium can have +2, calcium can have +2, right? So like that. Okay. So how do you know that? Is we can compare what is the nearby inert gas. Okay, so look at that. The inert gas are helium, right? Neon, argon, krypton, xenon. These are what? Inert gases. Okay, so which is closer to these, and then we can predict that. Now let's see. Let's go to the periodic table here. If you see the periodic table, look at that. What could be hydrogen? What is nearby? Hydrogen atomic number is 1. See, hydrogen's atomic number is 1. Okay, hydrogen's atomic number is 1, and its close is actually helium. You see that helium is close. Hydrogen's atomic number is 1, helium is 2, but the other inert gas is neon, right? Neon is farther. Neon is 10, hydrogen is 1. Hydrogen's atomic number is 1, helium's 2. Neon is 10. That's why what is the nearby of the hydrogen? Helium is the nearby of the hydrogen. Okay. So similarly, let's say lithium. Lithium is 3. Again, it is also helium is close. Okay. So similarly, let's say carbon. Carbon is 6. Let's say nitrogen first. Nitrogen is 7. Atomic number 7. Helium is 2. 5 farther away. And the neon is 10. 3 farther away. So neon is closer, right? Nitrogen is 7, neon is 10. But the other inert gas is helium. Helium is 2. So closer is neon. So nitrogen's argon also other inert gas, but the argon is 18. It's too farther away, right? So that's why some are close. And let's see that on the basis of this, what could be the charge of an atom. Okay, we will see that here. Now let's see. So charge of, first of all, let's calculate the hydrogen. What could be the charge of hydrogen? Hydrogen is exception. Okay, hydrogen is in the exception. So hydrogen is +1 also. It can be hydrogen is -1 also. Both, right? What is the nearby? Is the helium, right? Hydrogen is equals to atomic number 1. Helium is atomic number 2. Subtract that. 1 minus 2 is equals to -1. 2 minus 1 is equals to +1. So hydrogen can be -1 or +1. So lithium, let's say lithium's closer inert gas is helium, right? So lithium's closer is helium, because you see that here lithium is you see lithium is 3, helium is 2, right? That's why lithium is 3 and helium is 2, and 3 minus 2, then 3 minus 2 is equals to +1. So lithium's charge will be +1. Now let's search the magnesium. Okay, so let's go a little bit further. Magnesium, what will be the charge on magnesium? Magnesium is 12. And what is the close by? So close by are helium also. Helium is 2, neon is 10, argon is 18, right? So these are close. Helium is equals to 2, atomic number 2. Neon is atomic number 10. Argon is atomic number 18, right? Which is the closest? 2, 10 or 18? It's a 12. 10 is closest, right? So neon. Neon is how much? 10. Look at that. This is 12, this is 10. What is the difference? 12 minus 10 is equals to plus 2. That's why magnesium can have the charge plus 2. Okay. Similarly, calcium. Let's see calcium. Calcium is 12. Calcium is 20, right? So what are the inert gas below 20? Below 20 are helium 2, neon 10, argon 18. They are the inert gas below 20, right? This 20 atomic number. Out of them, which is the closest? Helium? Oh no, it's 18. Neon, it is about 10. No. Argon is 18. Argon is pretty close to the calcium, right? That's why Ca and argon. So what will be the charge on Ca? Calcium is 20 and argon is 18. That's why 20 minus 18 is equals to plus 2. So that's why calcium will be plus 2. Okay. So now this way we can predict the charge. However, it don't work for these transition metals, right? These stuff, these guys, these are they have lots of exceptions. But for the main group element, it acts. Okay. If you think about what will be the charge on bromine, if you see bromine is 35, krypton is 36, it's closer. Bromine 35 minus 36 is -1. That's why bromine could be negative, -1. Fluorine is 9, neon is 10, fluorine minus neon is -1. That's why it is -1 charge. Oxygen is 8. What is the closest to oxygen? The below oxygen there is one inert gas, which is helium, and above it is neon. So it is 10, neon is 10, helium is 2, and oxygen is 8. Means 2 is not closer. It is closer, but it's not closer than neon. Neon is 10. That's why 8 minus 10 is -2. Right? So in this way you can predict. For example, carbon. Let's say about what about the carbon? Carbon. See, carbon is what? 6. Right? Carbon is 6. And what are the closer inert gases? Helium and neon, argon. Let's see which one. Helium is 2, neon is 10, right? Argon is 18. Which is closer? How do you see that? So upper one is neon, lower one is helium. Helium is also 2 and neon is 10. So what could be the charge then? So it's a difficult, right? 6 minus 2 is equals to plus 4. 6 minus 10 is equals to -4. Which one you will choose? It is plus 4, it is -4, right? It is plus 4, it is -4. Can carbon be -4? No. Carbon is more positive. Okay, it will be plus. So if you have to select from plus and minus, it is plus. Like the hydrogen, right? Hydrogen has close by is it could be close by is the helium, right? So you can do, this is 1, this is 2. Either it could be 1 minus 2 or it could be 2 minus 1, right? That is the 2 minus 1 is plus. So these are the exceptions. Hydrogen is, right? So hydrogen can be minus and plus both. Carbon should be also minus and plus 4, but it's better to give the electron, so it is plus 4. Carbon. So this way we can predict the charge. Okay. So yeah, we have predicted the charge, and here are some examples. You can see the lithium plus, bromine minus, barium +2, and so on. Okay. So now let's do one example. Before our goal today is studying the electronegativity difference. Now, what monoatomic ion would you expect the following elements? Iodine. What could be monoatomic ion? I minus, I minus or I2 minus or I3 minus, what mono, or I plus, what could be the monoatomic ions in the iodine? Okay, so let's see that back to the periodic table. So iodine is atomic number, iodine atomic number is 53. So iodine is 53. Now let's go to the closer by. Okay, close element. Okay, now let's see that iodine is 53. Oh, xenon is 54, right? So xenon is 54. It's the close by is xenon, and that is 54. All others are farther, right? So all others are farther. So 36, other one is krypton is 36, right? Krypton is 36. It is 53 minus 36 is 2 way farther. Okay, so but the iodine is 53 and xenon is 54. Now subtract that. 53 minus 54 is equals to minus 1. So that's why iodine, is minus 1. And similarly calcium, we already did that. Aluminum, we already did that, right? Or calcium we did, and we can have the aluminum now. Okay, so let's see the aluminum. Okay, aluminum is 13, right? And closer by is helium, I is 2, right? And neon is equals to 10. Okay, argon is equals to 18. Which one is the closest? 13 minus 2, it is 9. 13 minus 2, it is 9, right? And 13 minus 10, it is 3, plus 3, right? Aluminum minus 18, it is minus 5, right? So which one is this? Plus are easy, right? If you have a plus and minus, so but this is 5, 2 farther. 3 is closest, right? So it is plus also. That's why aluminum will be 13 minus 10 is plus 3. So you select to which one is the smallest number instead of negative and positive. Means just to see the numbers. Or if you are in again the dilemma, then accept the plus. So now that's the one example. So now let's go again the molecule and the ion. Molecule and ion, two different species. Okay, the basic unit of molecular element or covalent compound consisting of two or more atoms bonded by the sharing of electron. So molecule means that kind of structures which are made by sharing of electron. Okay, so ions, those which are made by the donation or losing or gaining the electron. So either losing or gaining. So those are made by losing or gaining electron are ion, and those are made by the sharing of the electron are said to be the molecule. Sharing of the electron means covalent. If there is a covalent bond, then that is the molecule. If there is the ionic bond, they are the ions. Okay, these two definitions. Now let's see some element. Those can form in the form of molecule. Element, I am saying that, not the compound. So hydrogen is an element, right? But it is a molecule also. See, it is a molecule, but this molecule is not the ionic, because what is the let's see that this is the covalent. This is this hydrogen and hydrogen formed by the covalent bond. Okay, HH is the covalent because it is non-metal, right? So that's why this is the molecule. So nitrogen and nitrogen, right? So that's why this is also the molecule. Molecular elements, but those can be found in the molecule. Sulfur 8, selenium 8, chlorine 2, bromine 2, iodine 2, fluorine 2. These are the elements occur in the in molecule. So now the polarity of the covalent bond. Okay, so now let's go to the electronegativity difference. Okay, so we have a covalent bond and we have ionic bond, two bonds. Covalent bond if electronegativity is less than 1.9, then we will say that bond is the covalent bond. If electronegativity is difference is greater than or equals to 1.9, we will say that is the ionic bond. Okay, so that's the ionic bond and the covalent bond definition at first. Okay, if the electronegativity difference is less than 1.9, say that is the covalent. If it is greater than 1.9, that is the ionic. Now let's go back to the first slide is here. See, let's find out what bond can be. So HCl, hydrochloric acid, hydrogen and chlorine. Hydrogen is 2.2, chlorine is 3.2. So difference is what? Difference is electronegativity difference is equals to 1. Oh, this is less than 1.9, right? So electronegativity difference delta E is equals to 1, which is less than 1.9. Means less than 1.9 is covalent. So this bond will be covalent. Okay, HCl bond will be covalent. So similarly, magnesium chloride, MgCl2, right? In that we have a magnesium and one chlorine and other chlorine, right? So bond is between magnesium and chlorine. So magnesium chloride has magnesium and chlorine bond, right? So what is the magnesium? So magnesium and chlorine. Magnesium is 1.3 and chlorine is 3.2, right? It is about 90, means 1.9, right? Let's see, it is 1.9. It is about ionic. It is pretty much close to covalent, very very weak ionic bond. Okay, but this is ionic, 1.9. So calcium chloride is also the same, calcium chloride, right? So similarly, potassium chloride. Let's see the potassium chloride, potassium and chlorine. Okay, now let's see potassium chloride. Potassium chloride, is that ionic or covalent? So potassium and chlorine. What is the potassium? Potassium is 0.8, chlorine is 3.2. 3.2 minus 8. Oh, okay. 2.4. It is a 2.4. Okay, 2.4 is greater than 1.9, right? So that is ionic. This is ionic because it is 2.4. So similarly, others also you can find out, right? Lithium fluoride, LiF, for example. Lithium is 1, fluorine is 4. So what is the electronegativity difference? 3 is 2. This is this is the ionic. So so similarly, you can see that calcium oxide, CaO. Now let's see that calcium is 1 and oxygen is 3.4. So difference will be 2.4, right? Difference will be 2.4. So this is ionic because it's greater than 1.9. So we have that. So now we learned covalent and ionic, right? So what happens in the bond is that bond can be polar and non-polar both, right? For example, you have a covalent bond, suppose hydrogen and oxygen, right? This is the bond, this is the water. So hydrogen oxygen bond, here is also hydrogen oxygen bond. But that kind of bonds are polar bond, polar covalent bond. Polar covalent bond. Polar covalent bond means that in that case, one atom will attract more electron toward itself. Electron energy, it will pull the electron toward itself and become more negative. Okay, so what happens is, let's say first of all hydrogen and oxygen. Let's go to the electronegativity difference. Hydrogen is 2.2, okay, and oxygen is 3.4. right? And it is 1.2, which is less than 1.9. That is a covalent bond, right? But what happened is oxygen is here, here is hydrogen, here is hydrogen. Okay, so this is the hydrogen's electron cloud. This is the electron cloud, electrons cloud of the hydrogen. This is the another hydrogen's electron cloud, and this is oxygen's electron cloud. So what happens actually is these hydrogen's electron clouds are attracted toward by oxygen, because oxygen is more electronegative. You see, 3.4 it is 2.2, right? It is way less than 3.4. So one has a more electronegative, pretty much 1.2 difference. It's a huge difference, right? It is a more electronegative difference. So that's why the oxygen is more electronegative, then hydrogen is more electropositive. So what happens is it pulls the electron of the hydrogen towards itself, and this structure will form. Okay, so when it pulls the electron, then what happens is, let me erase these upper ones. So now what happens is, this is the oxygen, this is the hydrogen, this is another hydrogen, right? What happens is this electron cloud pulled by oxygen itself towards itself, and what will happen is a tiny amount of the electron cloud remain there, and more electron cloud will be accumulated here, and this will also be pulled out. So you see, so loss of electron cloud is located here around the oxygen. So in this situation, this place is about negative, right? Partially negative, not the 100% negative, but it has a negative character, negative charge, and that is denoted by delta. Okay, partial charge are denoted by delta, and yes, these are denoted by delta, right? And negative, partial negative charge, and this will have partial positive charge. Similarly, this has also partial positive charge. So what happens is, it has a two pole. However, these are weak pole, but two pole. Look at that. This is the negative pole over. This is the negative pole because delta negative, partially negative, and this is positive pole. So in this bond O and H, so what happened is, because of the pulling of the electron cloud, so one will be positively charged and other is negatively. Means that a same bond, it has a two pole. One is positive pole and one is negative pole. So this kind of bond are said to be the polar bond, polar covalent bond. Okay, these type of bonds are said to be the polar covalent bond. Okay, so then how can we classify easily? So if electronegativity difference is less than 0.5, it is non-polar covalent bond. Okay, if delta electron difference, okay, electronegativity difference is less than 0.5, that is a non-polar covalent bond. It's not polar then. Okay, so for example, carbon and hydrogen, CH bond. If you think about the CH bond, so let's go to the electronegativity difference. Carbon is 2.6, okay, and hydrogen is 2.2. So you see, difference is just 0.4, right? So it is less than 0.5. That's why this bond is not a polar covalent bond. Neither, no one will attract the electron cloud toward itself. Its electron cloud is with itself. Its own electron cloud will be with itself. It's not pulled by anything. Okay. So in this case, the difference is 0.4. So it's less than 0.5. So in that type of the bonds are non-polar covalent bond. Okay, they are non-polar covalent bond. So now if electronegativity difference is greater than 0.5, so let me write that. If electronegativity difference is greater than 0.5 and less than 1.9, then this is polar covalent bond. Okay, so now let's repeat that again. If electronegativity difference is less than 0.5, it is not non-polar covalent bond. If electronegativity difference is greater than 0.5 and less than 1.9, then that is polar covalent bond. That is polar covalent bond. Okay, so but if delta E is greater than 1.9, it is then ionic. So non-polar covalent bond, more electron cloud toward pushing, and finally all the electron cloud come is ionic bond. Okay, so let's see that polar and ionic bonds, right? How non-covalent, then polar, then more intensity increase, then it is a ionic. So what happened is, this is one atom and this is one atom. Okay, their electron cloud is with themselves, nothing attraction is there. For example, hydrogen and carbon. So this is electronegativity difference is 0.4, right? And this is not polar. Now let's say polar. Polar is hydrogen and oxygen. That's a polar bond. What happened is, you see, it has a tiny mini left here, all others are here. So this is about to stretch out from the hydrogen, right? This is polar. That's why delta positive, delta negative. This is a polar covalent. But still they are not separated. Hydrogen is still bonded with the oxygen. Now, if the ionic, now let's see that if, for example, the sodium chloride, let's say sodium chloride, sodium chloride, sodium chloride, and that is actually sodium and chlorine, and all the electron cloud it will give to the chlorine. This guy, in this case, in previous case, all the electron cloud is not given to the all the electron cloud is not given, right? Some electron cloud is here and lots of electron cloud goes to the oxygen in previous case. But this case, all the electron clouds go to the chlorine, right? Sodium don't have anything. Okay, sodium has just the positive charge and chlorine has negative charge, and chlorine pulls all of this one full electron. So here is hydrogen has no one electron, few portion of the electron. One electron, don't think that one electron means kind of one entity. It is the electron cloud, and out of that one electron cloud, lots of electron cloud is pulled by the oxygen. But in this case, everything pulled. So this is the ionic. Okay. So that's all about the covalent bond and the ionic. Now let's summarize that and then we will go to the next video. Okay. Summary. What is the summary? We studied how to calculate charge, how to get charge. And charge we can predict by comparing the nearby inert gas, right? So we will subtract its atomic number and the inert gas, closest inert gas atomic number, and that will be your charge. So that is one thing. And second is, we have studied two types of the bond, covalent bond and ionic bond. Two bonds, right? And we know that third is, what are covalent bonds if they formed by the metal and the non-metal and non-metal. What are ionic, metal and non-metal, like that. And the other thing is the electronegativity difference. We studied the electronegativity, right? That is tendency of the pulling electron towards itself. That is the electronegativity. So we studied that if electronegativity difference, so difference delta E, let's say its name is delta E. Okay, if we studied that if 0 to 0.5 equals to delta E, if delta E is 0.0.5, it is non-polar covalent bond. Okay, and if delta E is greater than 0.5 and greater than 0.5 and delta E is less than 1.9, and that is a polar covalent bond. We studied that. And third one, we have if greater than 1.9, then it is ionic. That's the takeaway for today. And what is another takeaway is, so the ionic, in case of the ionic, full electron transfer, but in case of the non-polar, no electron transfer, only the sharing, and in case of the polar covalent bond, partial electron charge are transferred, means that partially transferred, not fully transferred. So that's why lots of electron cloud pulled toward itself, and one become delta positive and other become delta negative. And this letter delta is representing for the partial. Okay, so this is today's takeaway, and next day we will study this one. See, this is the naming binary compound and binary covalent compound, and then for next day we will study the ionic compound. So that's it for now. We will go to the next video. Thank you for today.